Alright, so we have an adjacency list. Okay, that's step one. You're going to make an adjacency list, and when you do make an adjacency list, you don't really need to look at the graph anymore. You can just implement with the adjacency list. Okay, so the first step after the adjacency list would be that you create a table. Alright, and a table of visited. Here I'm going to mark whichever node has been visited. So if it's 0, if 0 is visited, I'm going to make a true. If 1 is visited, I'm going to make a true, stuff like that. Then after visited, I have my predecessor table as well, my predecessor column. What this shows is that whatever precedes the 0 is going to be put in this column. So it's going to make much more sense once I actually code this out. So I'm going to start at 0, right? Let's start at 0. The predecessor of 0 is going to be nothing, okay, because there's nothing before 0. And then since I started at 0, I'm going to make it true, meaning it's visited now, right? So t is, or 0 is visited. Next, what I'm going to do is that I'm going to say that 1, okay, I'm going to say that go to 8 because, oh yeah, forgot, you have to make a queue. Just pick a nice color. Okay, so we have a queue. I'm going to make a queue. You know what a queue is, right? If you don't, watch my video on a queue. Okay, a queue is the data structure. So this is where a queue is used, by the way. Now, the thing with a queue is that I'm at 0 right now, right? Now, whatever 0 points to, like is connected to, I'm going to throw it inside of the queue. So it's connected to an 8. So I'm going to put 8 inside of the queue. Okay, now the moment I put 8 inside of the queue, I'm going to mark 8 as visited. Alright, and once I do mark it visited, I'm going to see who its predecessor was. It was 0 because 8 came from 0. Remember, 8 was touching 0, so before we were at 8, we were at 0. Because there's no other number after 8, right? It's ended, so I'm going to pop the queue. I'm going to dequeue. Right, I'm going to take the 8 out now. Now once I pop 8 out of the queue, all of the numbers that 8 is touching, I'm going to put inside of the queue. 2, 0 and 9. Now all of them have gone into the queue. Now I'm going to say 209. I'm going to go to 2. 2 was here. I'm going to put mark 2 as visited. 0 was, okay, so 0 is already visited. So don't consider 0. Alright, so we're not going to put 0 inside of the queue. We're going to take it out. Then I'm going to see that 9, alright, so 9 isn't visited. Now I'm going to make it visited. And its predecessor was 8, and 2's predecessor was also 8, because it came from 8. Now you can see that 8, if you look at the graph, you don't really need to look at it, but you can see that 8 came from 0. So if I look at here, where's 8? 8, its predecessor was 0, and 2's predecessor was 8, and 9's predecessor, which is right over here, was also 8. Next, I'm going to see 2. Alright, now I've marked the predecessor, and I've marked it visited as well. So now I'm going to pop 2 out of the queue as well. Okay, so I'm going to pop queue 2 out. Now the moment I pop 2 out, I'm going to take all of the stuff that's touching 8. Alright, I'm going to throw it inside of the queue. But first I'm going to see if they are visited. So we have 8 here. Now 8 is visited. Remember, it's true. So I cannot put it in the queue. 1 I check. Okay, 1 isn't visited, so I put 1 inside of the queue, and I mark it visited, and it came from 2, right? So I'm going to put predecessor as 2. Next, I see that 4, now 4 isn't visited, I mark it as visited, and I put it came from 2. So I'm going to put 4 inside of the queue as well. Done. Perfect. Next, what I'm going to do is that I'm gonna, like right now, I'm gonna see 9 and I'm gonna pop it out of the queue. Now once I do pop out 9, I'm gonna put all of 9's elements inside of the queue if they're not visited. But 1 is visited and 8 is also visited, so yeah, we cannot put it in the queue. Okay, then I'm gonna say I'm gonna put 1, I'm gonna look at 1 and I'm gonna put its elements in the queue. So it's 3, 7, 9, 2. 3 isn't visited, I put it 2 and it came from 1. So I put 3 in the queue. Then I'm going to see 7. 7 isn't visited. Make it true. It came from 1. I'm going to put it inside of the queue. Then I'm going to see 9. 9 is also, okay, 9 is visited. 2 is already visited, so leave that. Then I'm going to see 4 is inside of the queue, and I'm going to pop it out of the queue, and I'm going to put 4's elements inside, but both of them are visited, right? 2 and 3 are both visited, so I cannot put them in the queue. Then I'm going to check 3. I'm going to pop its elements, and I'm going to pop 3 and I'm going to put its elements inside of the queue. 4 is visited right over there, so I can't put it in. 5, however, is right over here and it's not visited, so I'm going to put 5 there as true, and it came from the 3 because here's 3, so it came from 3. Alright, now I'm going to put 5 inside of the queue, and then I see 1 is already visited, so I don't put it inside. Then I'm going to pop 7. Alright, so 7 has been popped from the queue, and it's 1 and 6, so I'm going to make this true, and 6, yeah, it came from 7, so I put 6 inside of the queue now. Alright, so now you can see that all of our nodes are visited, and here our queue is full. Actually not full, but there's still elements inside of the queue. You're not gonna stop BFS until our queue is empty. Okay, so I see 5, I'm gonna pop 5, and we can see that 3 and 6 is already visited, so we cannot put any of 5's elements inside of the queue. Same with 6, I can see 7 and 5 right over there. Once I pop 6 from the queue, right, you can see that 7 and 5 are both visited, and I cannot put them inside of the queue. So yeah, there we go, that's our BFS that's implemented.